Hi, in this video, we're going to take a look at document clustering, and we're going to use Dungeons and Dragons Adventure League Adventures to do this. Okay, so the main focus, honestly, is on document clustering in this video. We're using Dungeons and Dragons just as a source of documents. So hopefully, this is interesting to you. I'm hoping to get some excitement in the videos, but honestly, from a data science point of view, it doesn't really matter what I'm working on. All right, so why would I cluster documents? Well, why would you cluster your data anyway? So a couple of different reasons. Maybe I want to group my documents, just like grouping my data into similar groups. I want subgroups where all the data are similar to each other. All right. Or maybe I want to do outlier detection, or maybe I want to be able to understand what's in my data better. So by doing clustering, what I can do is I have subgroups. I can take a representative from each subgroup. So like in k-means, I take the centers, and PAM partition around the medoid. I have a representative from each cluster. And that can be a representation of what's in my data when I have way too many rows of data for me to wade through. And so I personally run clustering on almost every project that I come across, even if it doesn't go to stakeholders, just so that I get a better idea of what's in my data. All right, so some more practical reasons, more direct. Let's say I want to discover hidden patterns and themes in my data. All right, so since I'm working with documents, I can actually pick up themes on the groups of that I get from my clustering. And so now this is not as good as topic modeling. This is not as good as one-shot classification using an LLM, but this is a tool in our tool belt, and this is basically a byproduct of what we would be doing anyway off of this. Now, what we could also be doing is organizing our, a large data set. So let's say that I just have a whole bunch of documents that I have to get through. It's too much for me. Maybe I'm on a team, and you know what? All right, we're going to organize by similar documents into groups, and then each employee or each team gets a cluster from that. And so imagine, let's say politically, or in a legal battle, documents are released, and because like they're subpoenaed, they're forced to. Now, the opposition does not want to help help the other side understand what's in those documents. This could be for like a political release of documents. This could be like a legal subpoena. So say like there's a lawsuit or something. The other side hands over all the documents in the most difficult format they could possibly deliver. And then the other side, and they do it at the last minute possible. And then the other side, they've delivered the documents. The other side has to do something with it. All right. So what they can do, they can scan it, and then they have to start reading it. Well, if you hear this in the news, that just tons and tons of documents, scan it in, convert it over to a text data format, do a document term matrix of some form, then start grouping them, start analyzing, and that way we get an idea what's going on in these documents without having to read each and every one, and that can help speed up the process. Also, if I have teams that are working on similar documents, I'm making my teams like specialists in what's going on instead of generalizing across the whole entire space. Advantages and disadvantages in doing that. All right, now we can improve searches and recommendation systems. All right, so if I have a search or recommendation system for a bunch of documents, then by clustering, I can try to anticipate what's more likely to be the answer to somebody's question, or come up with improve a recommendation system aspect. We can also do customer segmentation. And so, by doing this, we can try and get customers that have similar comments together and, address their needs individually, and not individually, but as a group that is tuned to what the group as a whole would respond to. Also, market research, research analysis. Basically, anytime that I want to understand a lot of documents without having to actually read them individually, document clustering is a good way to go. Now, we're going to be using a bag of words approach. A bag of words approach is like a keywords model across the board, but like much bigger. I'm going to take my data, And we're going to take the counts of the frequency of words in each document, and that's going to give us a numeric value. All right, now in this, we're going to lose a lot of data, okay, or a lot of information that the original sentence had. For example, these two sentences will have exactly the same data for a document term matrix. The dog bit the boy, and the boy bit the dog. All right, in those sentences, we know that there's a boy, we know that there's a dog, and we know that somebody was bit if we look at the document term matrix row of data. But we wouldn't know who bit who. All right. So there is some information loss. If that's a problem, we probably want to use an NLP approach, or we could also do a large language model. Now, one of the things that's super important about classic text analysis is that right now, companies have not gone 100% on LLMs yet. LLMs are still being vetted. They've improved a lot in the last 6 months, specifically in summarization. That's where I see the biggest improvement. But before a company is going to go and put in a lot of risk into trusting an LLM, they're going to want to vet it and understand that this LLM is going to perform as intended, that they want it to be safe to buy. All right, so we still need to use classic text analysis, because what we're going to do, I'm going to run classic text analysis so I understand what's going on in the classic approach, and then I'm going to run the LLM, and I'm going to compare the results to understand what's going on. Hopefully, preferably, the tasks have the same goal, but not always. And sometimes we have, the classic approach and the LLM task don't match up exactly, but we still do this to make sure that I understand what that LLM is going to do, and evaluate how accurate it's going to be. Is it going to perform as I need it to when we put it into production? Okay, so I'm going to have a lot of numbers in front of your face later on. So I'm rounding off to 1 digit, and I'm avoiding scientific notation as much as possible. I always do this before I start a project to get rid of any artifacts floating around. And I'm going to use piping, and I'm going to use ggplot. All right, so in a previous video, I went through and I built the document term matrices. I did a whole bunch of different variations of that. If you don't know which one to use term frequency, inverse document frequency. Overwhelmingly, if you don't have a reason to go otherwise, use term frequency, inverse document frequency. There's very few situations where really you would deviate from that unless you have a very specific reason. So kind of like if I wanted to keep the numbers easier for my stakeholders, I might just use a raw count. In that situation, I would want to be using documents of approximately the same length, very consistent length of documents for that. That's probably the main time. That would be a term frequency document term matrix. All right, so let's go ahead and, so this is going to be the original data, and I'm going to filter out anything that has empty rows of clean data, or clean text. So here's the document. So remember, we're talking about Dungeons and Dragons Adventure League. So this is from the 4th season, first adventure, Suits of the Mist. This is a tier 1 adventure for levels 1 through 4, campaign 4, adventure 1. This is this page number. So in this document term matrix, each individual page corresponds to a document on this one. Here is the word count of the original. Here's the character count of the original, and here is the cleaned version. And so here I can get an idea of how much did the cleaning of text reduce what's going on. So here's the original text. Now here's the clean version of it. And not everything is, this isn't a grammatically correct sentence. Everything's all nice and clean. I've removed stop words, I've removed punctuations, I've removed numbers. And so each individual project, the way you do your data prep needs to be decided upon, what are you doing? If numbers were important, let's say I needed addresses, then I would not need to remove numbers. All right, so here I've got PO Box. Here is PO Box right there. Now I know that does not relate to Dungeons and Dragons, Forgotten Realms. They don't have PO Boxes in Forgotten Realms. So because of that, depending on my project, I might have to go through and filter out the the legal information, the headers and the footers, which I did not do in this project because it's, this isn't for work. I just want to get the video out the door. All right, it's good to have a good document IDs on your documents. And so now I'm going to load my document term matrix. So now here, this is all of the document term matrices that I built in the previous video. The only one I'm going to use is going to be the term frequency, inverse document frequency with normalization. The normalization is the default one. You can also take the normalization off. Okay, so when we take a look at this, here is what the data looks like when I do the inspect. So I just see first few rows, first few columns. I can see the number of non-sparse entries, number of entries total, number of documents, number of rows, number of terms, number of columns. Remember, document term matrix. We always do rows, then columns when we talk about matrices. So document term, document is first, that each document corresponds to a row, each term corresponds to a column. And so maximum term length is 12 as the longest word in there has 12 characters, and we can see what the values are. Okay, so let's do hierarchical clustering. Now, this data set has over 5,000 rows of data. If I want to do hierarchical clustering, I'm going to have to create a 5,776 by 5,776 square distance matrix. Only, a little bit less than half will actually be computed on that. But if you think about it, if I do nChoose2, that's going to be a pretty big number on there. All right, so when I do nChoose2, how many times do I have to do a computation? It's quite a bit. It's going to take a long time. Let's say I'm in a situation where I don't either have the time or I don't have the computational power to do a proper distance matrix. All right, so what I'm going to show you to do is to do what I call start in the middle. And I believe that's how SAS calls it. I got this from when I worked in SAS professionally. They have this as a nice feature in there. I haven't seen it in Python. I haven't seen it in R. I'm sure it's there somewhere, but when I don't know the name, but when I was working in SAS, it was called start in the middle. What we're going to do, we're going to do k-means clustering, and then I'm going to do hierarchical clustering on the centers that I get, and I'm going to do hierarchical clustering within each cluster. And then I can paste them together to create a large tree for the entire data set. Now, when I have a lot of rows of data and I want to do hierarchical clustering, I have several options. I don't have to start in the middle. So first and foremost, I could filter out rows to cluster fewer records, filter out columns, keeping only the most important ones to reduce the number of computation. I could perform dimension reduction, or I could start in the middle, run a fast partition cluster, k-means, run hierarchical clustering on the centers, run hierarchical clustering on each partition cluster. And so here, start in the middle. I've never done a video about it before. I've never honestly implemented it at work, but I know it's a tool in my tool belt, so I wanted to just run it and go with it. So we're going to do start in the middle. We will set the number of clusters to the square root of the number of documents. And so the term frequency inverse document matrix are automatically scaled. So I'm not going to center and scale my data. If I had like term frequencies or some form of not rescaled document term matrix, I would center and scale my columns before I run this. But I'm going to run k-means without center and scaling, since it's a term frequency inverse document frequency. That inverse document frequency with normalization, I'm just going to run it as is. Okay, so I'm going to run k-means. So here is my document term matrix. It's a term frequency inverse document frequency. And then I'm going to take the square root of the number of documents I have, number of rows, and I'm rounding down. If you don't know how many clusters to go with, round down, go down. Don't know, go low. That way you have a simpler model. All right, and so now what I'm going to do, I'm going to take the centers from my k-means model. I'm going to compute the distance function between them. Then I've got a hierarchical cluster I'm going to run. I'm going to choose to use Ward's D. The default is single linkage. I could have also, or sorry, the default is complete linkage, which is most accepted by the scientific community. Ward's D does a good job of approximately equal groups, while single linkage does a better job of outlier detection. And then let's go ahead and plot it. And so you can see I've got two major groups going on among my centers. Now, each of these leaves in the dendrogram represents a collection of documents that are inside each cluster. So here, each of these represents a cluster of documents in the k-means model. All right, so now what I want to do is I want to start going through and doing k-means clustering. Now, one thing's going to happen if I have very few documents in a cluster, it's not going to make sense for me to cluster it any further. So what I'm going to do, those clusters that have very few documents in them, I'm going to go ahead and bin them because I was having issues with combining that. And so here I'm replacing the clusters, or I'm taking sparse clusters and putting them into one group. That way it prevents errors that I was getting in the computation. And so now I'm going to go through and I'm going to run, I'm going to do a distance matrix on each of the documents inside a cluster. And then I'm going to do a hierarchical clustering for each and every cluster of the k-means model. And so I've got k-means model, put a bunch of documents together. And so I have a smaller group of documents. It's a smaller group, so I can do the distance computation now. I couldn't do the distance computation on the full data set. What I did was I said, hey, these guys are similar to each other. I'm going to run the distance matrix on them because I know that these guys are going to end up being close together. When I have two documents in different clusters off of this, realistically, it's a waste of time to compute the distance between them because they're going to end up being in different regions of the dendrogram. It's not worth the time to compute it, but I don't know that until I do some other computation. And k-means did that for me. All right, and so here I'm going to just show the first, let's say, 5 dendrograms that I've got. So here, this is all of the documents in the first cluster itself put into hierarchical clustering. Now here's the second, like, oh, look at that. That looks like an outlier to me. Huh, that's interesting. Oh, 82, row 82 is also an outlier, huh? Okay, I might want to check that out. Oh, 2047 is also sticking out. So, I can see some patterns. I've got some information about what's going on. I can see which documents are very similar to each other real easily off of this. Outlier once again, huh? Okay, so this is a pretty outlier heavy data set. So, I might want to have to do something about this, start digging in. All right, so let's go ahead and take a look at the centers, and let's say take a look at what we've got. And so here we've got, for the centers, we've got what are the most common words off of the first center that we've got. And so we've got hand, part, appendix, Dungeons and Dragons Adventure League, map, piece, slot, level, hit, spell, mage spell casting, result, vice, page, player, show, head, coast, wizard, league, adventure, material, dragon. So we know that Wizards of the Coast is going to appear all over the document. So when I see wizard, that could be from like a wizard in the game, or it could be from Wizards of the Coast, the name of the company. I have to know that. When I see league, I mean, it could be, I can't think of a league in Dungeons and Dragons, but let's say, League of Shadows, League of Assassins from DC Comics. Either that could be like a league of bad guys, league of good guys, or that could be, Adventure League. Here we've got adventure. And so most of the time when I see adventure, I probably see league coming right after it. Now a mine, oh, hey, and that's rather large in here. So probably, the adventures in here take place in mines, maybe like Mines of Phandalin or something like that. Handout, player, map. So here I've got handout, I've got appendix, I've got map appearing twice. I need to fix that, figure out what's going on. All wind, blue, downtime, receive, conclusion. All right, so here, I mean, that's towards the end of the document. So, all right, so we might be, like this cluster might be focused towards the end where we have the appendix, we have the map, we have the conclusion aspect, the rewards for the renown, tips for running the adventure, things like that. All right, so yeah, so each of these here, I've got the words for each of the clusters. And so I can get an idea of what each cluster might be showing me. All right, so now let's go through and let's put them together in a manner that sets it up so that I can, you take all the documents and put them together. So what I'm going to do is I'm going to put all the adventures into just one. So the original term frequency inverse document frequency matrix was page by page. Let's say I'm not interested in page by page documents. I want it to go across the entire adventure. All right, well, let's do that. So I want to know, like, what are the groups of individual adventures so I can understand as a dungeon master what I would be getting into as I go into each individual one. All right, so when I did this, I went through and I found all of the edition of the documents. And so each row corresponds to either a document like that was exterior, like this one's a Druid's Vow, has a bunch of extra stuff, extra documents, or it's an entire adventure on its own. It kind of inconsistent about this. I'm using the Tidyverse version where I've got document, I've got word, I've got score for TF IDF. All right, so this is a more compact way to have sparse matrices, and we have sparsity in this. All right, so now let's go ahead and pivot wider to put this into like a classic document term matrix format. So what will happen if a word does not appear in a document, that word column document, the words column, the documents row will have a 0 in those situations. And so filling in missing values with a 0, and boom, we can see, like, for example, this adventure, which is Dreams of Red Wizards 1, does not have the word crocodile in it anywhere. Okay, but the first one does have something to do with crocodiles. And, we can go through and take a look, like, so here, the second Dreams of Red Wizards adventure has Oceanus. Oceanus is a river that goes through the morally good plains, like the river Styx goes through the morally evil plains. So, and here this is a monster species that's like water creatures, kind of like really mean mermaids. All right, and so let's take a look. All right, so let's see, what do we have for this week? All right, so here I've got each of these documents and I've got their cluster. Okay, let's go ahead and visualize the cluster. Boom, look at that. Okay, so when I visualize, you'll notice that I've got Business in Parnas, Dungeons and Dragons Expeditions League, 2.5 starts the flame. So this is, that is the elements of evil, campaign, their 5th adventure, and 8, I believe that is Waterdeep, A Wrinkle in Time, I think it is, and then everything else kind of appears here. Now, this plot, this visualization, I use principal component analysis for this. All right, so when I do this, the reason why I do this is that from this point of view, I can see that these 3 are very different from the other documents. These 3, at least in terms of the words that they use, are very different than all of the others. Okay, so what my cluster model has done, it's done outlier detection for me. All right, that's really not what I intended, but I still get a good result. So what I could do, if I really needed to accomplish a task off of this, I could go through, take these out, these three out of the data set, rerun clustering all together, rerun my code after filtering out those three, and then see what I get if I want to go further with this. Now, if I want to see the actual plots themselves, I need to remove the geom text off of this. The geom text that put the document name on there. And you can see that they're all on top of each other. Impossible to see what's going on. All right, so now let's go ahead and plot things out. All right, so here I'm just looking at cluster 1. So if I take the dots that correspond to cluster 1 and I zoom in really, really tight, this is what I would see if I remove the words. I removed, was it cluster 5? So I probably could get rid of cluster 5, honestly. And then, take a look at these. All right. And so here I've got, something to work with. All right, so let's take a look at the center. So here, if I want to understand what's going on, when I see a positive number off of this, so in this one, I did center and scale. Did I center and scale? I think I centered and scale. Pretty sure I did. Yeah, I definitely centered and scaled before I did my clustering on this one. All right, so when I see a positive number, that means that word appears more frequently than typical for across the documents. And so we can see the first cluster corresponds to the first rows pretty consistently. Then eventually we start seeing some other things. So third group has Ragnar in there. Let's see what else is interesting. Oh, okay, look at this. Brandyman, Gothard, Gundolin, Kagrota, Parnast, Trove, Wallace, Festing, or actually Festing's not part of it, but so we can see that the documents that have certain words tend to be in the same groups. And so here, when I see a positive number for a center, that's indicating that that word appears more frequently in those documents, those adventures, and others. Scroll all the way down to get to the end. All right, like Spore Dome. That's an interesting word. Spore Dome appears way more frequently. Now, when I interpret these numbers, since I centered and scaled, if I see greater than 2, that's a big whoop-de-doo. If I see less than -2, that means it appears very little in the aspect. So we want to use like standard normal-ish to kind of judge what's going on with this. So like 0.004 is not much for this. Like Koatoa do appear more frequently in group 1, but not a lot more than the others. All right, that's all I've got for you. I hope you've enjoyed this video. Life is short. Do math.